Hello, my name is Ariff Kenichi bin Ahmad Zaki Akira, matrix number 191392542 from ROI41. In this video, I'm going to talk about the CAA2 PGT205 signal system. So in this CAA, they only have one question, and it's related to the Laplace transform. So for Laplace transform, uh, base, it it convert from time domain xt into a frequency domain s by breaking down the exponent component, exponent negative st. So let's look at the question. So in this question, we are required to find the ROC of each of these function. So let's start with the first one. So let's have A, B, C, D. For my matrix number is 2542. So A is 2, B 5, C 4, and D is 2. So we substitute the value into the equation here, function, and we're gonna Laplace them. So basically to Laplace it, basically the value of exponent given here, we're gonna multiply with the uh, exponent exponent component negative exponent negative st, and we're gonna integrate it. So we just do a normal integration calculation here. Take note here is where exponent negative infinity is actually equals to 0, where exponent 0 is 1. So from here we can just identify which is 0 and which is 1, so we can get this answer. So after we simplify, we can get this final answer. Okay, for the ROC taken from this bottom part here, we can find the value of s for each of the numbers, and we can identify the ROC with more than or less than by looking at the time domain here. When it's positive, it's more than. When it's negative, t is less than. So we can identify here, and we can check whether it's go to the right or to the left. So in this question, with my matrix number, I found out that this function is not, there's no common ROC. It does not converge. It's a divergence. So how is that? Basically, how is common ROC is where all of these uh, function meet up at the same spot. So if I have four of them, all four of them need to uh, at the same location. So let's see the next one. Basically, the next one, B, is same as the previous question, but only the time domain is mirrored. So basically, it's mirrored from the previous line. So in this here method, I'm using the table, so referring to the table. So basically, exponent negative 2t. Basically, we refer to the table is over here, exponent negative 80, and here we basically substitute the value over here. So that's all. So the answer should be the same as previous, only mirrored. So negative in the front instead of positive. And this drawing, we're gonna similar like just now. So I've this ROC also is not common. There's no common ROC, does not converge, and it's a divergence. So for the final question, uh, it is required to do the inverse Laplace. So given this equation, substitute in the value of a, b, c, d, and we can find the partial fraction using taking the bottom here. Um, and finally, we just gonna find the value of a, b, and c. This is basically what's called just a normal calculation. So in the end, we can get this value. So to draw the ROC, so we can directly see the table and get the answer of like this. This is the rightmost. This is very common. No, typically we write it down like this, but in case of this, the question doesn't state anything. So there's four options for the answer. So option 1 is the rightmost, where all is the positive, the ut. So the converge is over here. The common ROC is more than 4. For option 2, it basically everything is negative t. So it's converged on the left side instead of the right on top here. So option 3 is converged over here. It's between the negative 2 and 4. Here ROC is the common ROC. So this direction where it's ut, then negative t, and then ut. Then finally it converge between negative 5 and negative 2. So sorry, then in here basically the common ROC is ROC is negative 5 less than RE. Basically like this. I forget to write it down. So the common ROC is negative between negative 5 and negative 2. So this is the answer. So t, negative t, and negative t. Then that's all from me. Thank you.